Okay, hi, my name is Elizabeth Dancy and I did my project on Jupiter. And little fact about Jupiter, it's actually named after the Roman god. The king of gods actually Jupiter, so I personally call it the king of all planets. And that's pretty fitting for the name, or for the planet Jupiter, since it is actually the biggest planet in our solar system. So big, in fact, that all the masses of the other planets in our solar system combined, Jupiter would still be twice as much as that mass. And like I said, Jupiter is the largest planet. It has a diameter of 88,846 miles, and that diameter is 11 times larger than Earth, so very large. And it is also a Jovian planet, meaning it is a gas giant. So it is composed of 81% hydrogen, 18% helium, and has trace amounts of methane, ammonia, phosphorus, water vapor, and hydrocarbons. And it's actually the only gas planet that we know of that has water vapor. And some more composition facts about it. It has 3 layers. And the first layer, the outer mantle, which is kind of its surface, but not really a surface, is mostly hydrogen, and that's being liquefied because of how much pressure is under. And then there's the inner mantle, and the pressure of this layer is even greater, that it's stripping the hydrogen of electrons. And because of that, it makes the hydrogen actually metallic. And this metallic layer is able to conduct electricity, and it forms a magnetic field around Jupiter, which is very, very strong. And then there's the core, which is 10 to 15 times the size of Earth, so still very large. And it is kind of unknown of what it's made out of. Some people say it's rock and ice, but others say that it's like a dense hot soup of iron and other silicate materials. And it gets pretty hot down here. It gets around 90,032 degrees Fahrenheit. And here's a picture kind of showing the different layers of the mantle. Of course, yellow would be the outer layer, and this kind of bluish be the middle layer, and then we have our core down there. And then the atmosphere of Jupiter is going to be gas, of course. The whole thing is going to be gas. So the average temperature of this is going to be around negative 200 degrees Fahrenheit, and it's also made out of a 3 cloud layer system, similar to the other mantles that I talked about. And this cloud layer spans 44 miles down into the planet. So the top cloud layer is going to be composed of ammonia ice crystals, and then the middle cloud is going to be crystals of ammonium hydrosulfide, and then the inner cloud is going to be made out of water vapor and also water ice. And then here's, oh god, and then here's a picture of it. Troposphere here. Here's our ammonium crystals and our water clouds down there. And if you look at Jupiter, it has these reddish brown, white stripes, and this is caused by sulfur and phosphorus containing gases rising up from the planet with the convection currents, and then those gases sink back down to the bottom once they cooled, and kind of creates that process. That's why we also see the swirling of Jupiter. And we see the separation of these stripes because of fast jet streams, and scientists don't really know why the jet streams form. They think it might be due to ammonium gas moving up and down within the planet, because that kind of has correlated with the jet streams. But these jet streams can reach 325 miles per hour, so very, very fast. And along with these jet streams, there are some very strong storms that can form. The most famous one is a Great Red Spot, which is the one you can see looking at Jupiter, the very prominent red dot. And this has been raging for over 300 years, so very, very long. And scientists think that its longevity is due to it not coming into contact with land, since there is no land on Jupiter. It's all gas, so it doesn't have that problem. And the Great Red Spot is able to complete 1 counterclockwise turn every 6 days, and the winds in the storm reach up to 270 miles per hour. And not only has the Great Red Spot been a prominent feature that people have noticed, but also smaller storms have started to form as well. like one called the Little Red Spot, which is 3 storms that kind of just like merged into one and now have created one bigger storm. And then right here, Great Red Spot, pretty big. A little orbit information around Jupiter. It's 5 astronomical units from the sun, while Earth is only 1. And 1 year on Jupiter is very long. It's 4,333 Earth days, or around 12 years. And they do have long years, but their days are very short. 1 day for them is 10 hours. And they have an orbital velocity of 13 kilometers per second. And that's different from Earth's because we have about 29 kilometers per second, so theirs is much slower than ours. And they have a semi-major axis of 778,479,000 kilometers. So it's pretty larger than ours, so their orbit is going to be longer. And then there's a visual just to show. And now this was something new to me. All gas planets actually do have rings. You can't see the rings on Jupiter. They're very faint. You can't really see them from Earth because they're hidden in the shadow of the planet. And they're 3,700 miles wide, so they're still pretty large. And they also have a 3-layer structure. Surprise, surprise. They have the halo, the main, and the gossamer. And then these rings are composed of rock fragments, but they're very small. They're about the size of smoke particles. And these fragments come about by asteroids or other meteors hitting the surrounding moons that Jupiter has, and this kicks up the dust, and then it gets pulled into the pole of Jupiter. And that shows gossamer rings there. The halo ring is the closest, and then the main ring right there, which is a smaller one. And Jupiter is actually a planet that has the most moons of our solar system. So far we have confirmed 80 moons. 57 of those moons have names and 23 are still waiting. And there's 4 moons that are very prominent, that are very well known. They are the Galilean moons, and these include Io, Europa, Ganymede, and Callisto. And these Galilean moons were named by Galileo because Galileo was the one to actually discover Jupiter. He saw Jupiter, he saw the moons surrounding them, and he thought they were stars, but he realized that they were actually celestial bodies, which kind of changed the way that astronomers thought in those days. And these Galilean moons are actually part of the 7 largest moons in our solar system, and they were most likely primordial, which means that they formed while Jupiter was also forming in our early days of our solar system. So the first moon I'm going to talk about is Io, and the 4 Galilean moons, they're kind of interesting because their names have ties to Greek and Roman mythology, which I think is kind of cool. So the story with Io is that she was a priestess to Juno, which was which was a wife of Jupiter, and Jupiter started to get a little bit of a liking to Io, and Juno did not like this at all. So she wanted to go after Io, ruin her. But Jupiter wanted to save her, so he turned her into a white cow, and he turned himself into a black bull. But Juno knew something was up. She was like, yep, my husband is tricking me. So she sent Argus, which is her bodyguard kind of, to go guard all of the female cows. And then Jupiter wanted to help Io escape, so he sent his son Mercury to go kill Argus, and then Io was able to run free. But that didn't stop Juno. She put a curse on Io to always have a gadfly sting her hide in her cow form, which kind of fitting for Io because she got too close to Jupiter and now she's suffering for it, just like the planet, because Io is pretty close to Jupiter and has lots of tidal forces within the moon causing havoc in volcanoes. It's actually the most volcanic body in our solar system. And these tidal forces generate all the friction that makes these eruptions and all the volcanoes. And so, of course, with all these volcanoes, it's very, very hot It's 1/3 of Earth's size, but generates twice the amount of heat and is very bright. And the most prominent volcano is Loki, which very, very hot. It produces 15% of all heat that the moon gives off. And the next moon is Europa, and this story involves Europa, which was a maiden of the day, and she was off with a group of her friends picking flowers, and Zeus, which is the Greek counterpart of Jupiter, noticed her and was interested in her, so he turned himself into a white bull that smelled of flowers, and then all the maidens started to pet him and were like, oh, look at this bull, he's so nice. And he sat down in front of Europa, and Europa climbed on his back, and he started to take off towards the sea, start sprinting towards the sea. And Europa realized, oh, this must be a god, and she started pleading and begging for his forgiveness. And that's when Zeus was like, no, I love you, you're gonna come with me and live a happy life and have my children. And all that was just kind of happening in the sea while she's panicking. Anyways, it's kind of fitting for Europa too, because Europa is covered in a layer of ice, but below that ice is a very vast ocean of water. It's the biggest ocean of our solar system, actually. And so Europa has very little tidal forces, so it's just enough to keep the surface beneath it liquid, but the crust over it ice. And the story for Ganymede isn't that interesting. It's just another lover of Zeus. It's kind of basically it. But it's actually the biggest moon known in our solar system. Has a diameter of 3,270 miles, and it's actually 3/4 the size of Mars. And it's so big, in fact, that it has its own magnetic field, which is pretty cool. Callisto also, the story isn't that interesting. She was a nymph, and she was very dedicated to the goddess Artemis, and she made a vow of chastity. But Zeus started to lure her in, and Zeus even pretended to be Artemis. And so then stuff happened. Callisto had Zeus's child, and then Artemis got really mad at her because she broke her vow of chastity and turned her into a bear. But yeah, doesn't really relate to the features that much. Still kind of interesting. But Callisto is slightly smaller than Mercury and has many craters that covers the surface. But cool thing, there has been absorption lines that have been sent back that show promising ingredients for life, and it has salty oceans that kind of interact with the rock just like Earth does. And there's even detection of oxygen, which is pretty cool. So scientists have been looking at the moons of Jupiter as a place where humans would be able to survive. But of course that needs more studying. And there has been other explorations to Jupiter already. There has been the mission of Galileo and the Voyager, but the most recent one has been the probe Juno, which was launched in 2016. And I think it made the orbit into Jupiter's orbit in 2021, so kind of recently. But cool thing is, it's actually been approved to extend its exploration and learn more about the planet. And so that'll continue into 2025, or just kind of whenever the probe dies and gives out. And so Juno will, of course, look for more information on the planet of Jupiter, but it'll also look for information on the surrounding Galilean moons, and also get more information about the rings itself. So pretty cool stuff. Pretty cool planet. And that's my presentation. Here are my sources, and then my sources for my images are linked to my images as well.